on in the background, addressing all of those questions, and it will be shared in due course. As you all know, when we've been on some of these Zoom meetings, if we all talk over each other, it'll be carnage. So the aims of this platform is to create a platform to connect with our engineering delivery community across TFL and the BB wider business. And it's to share knowledge and build on and capture any specialist expertise in the ITT, which we know we have lots of. And it's also a good platform where we can advertise how great we are and what we do. So next slide is just the purpose and the aim. So again, it's to share knowledge, and what we want to capture is the personal experiences around the renewal expertise. So we want to discuss the difficult jobs and the successful ones. Both make ITT a success. So we've set up a ITT Engineers YouTube channel. So the link will be sent out. It'll be attached to the invite as well. So the last two sessions are on there already, and today's will be up there after this. It's a great channel for us. It's good that we can have them there, and it's a good reference point as well. The defect-free delivery one's up there. We're going to hear a lot more about defect-free delivery when we remobilize. As you're all aware, when we get back to site in the new world post-COVID-19, we will have to be leaner and more defect-free than ever. So John O'Sullivan's very knowledgeable drainage delivery presentation is up there as well. And as I said, Dan's will be up there by close of business today. So this is a collaborative engineering community across TFL and Balfour Beatty Global. We want to learn from one another, and we want to feel like one team. It's a great channel to spread the word and gain exposure for ITT and the great stuff that we do. We are world class, and we are at the very forefront, and I believe we're the best at what we do. So these knowledge sharing sessions should improve safety and quality, and should bring down our accident index and reduce snagging and rework.
All right, Damien.
Yeah.
It's Steve here.
Hiya, Steve.
Yeah, good. Thanks for inviting me.
You're more than welcome. If we could just have your mic on mute for now, Steve, and then we're going to have an interactive part, if that's okay. Thanks for joining. So we just go on to the Kahoot slide. Next slide, Vid. So the number for Kahoot is, I'm sure Vid will reveal it. All right, so the Kahoot number is going to be revealed later on. So these things change with each meeting. That's why we can't send out a generic one. So feedback for these, that's the links at the bottom there to the ITT knowledge sharing on live link and the ITT knowledge sharing on YouTube. So what we want in this is we want some suggested content, ideas to promote knowledge sharing, how we can use this forum better to increase collaboration across the wider business. So in the first instance, if you send emails to me, that'd be great. We have a long list of people that have volunteered to do these, from night supervisors, delivery managers, senior supervisors, engineers, and the senior team. So it's good that everyone across the board is getting involved. We want some people from TDU to do some as well, so we'd like some volunteers for that. So as I said, we've created a folder for knowledge sharing on live link, and that was an idea from Anna Copio from the first session. So we've actioned that. So now for the main event, ladies and gentlemen. So we're looking forward to Dan Onose doing his DTR delivery presentation. So Dan's going to be touching on the unique challenges and absolute expertise that is absolutely unique to ITT working in the tube. So Dan has 16 years experience in predominantly concrete at track. So as a site engineer on Track Alliance, we delivered DTR projects across the Central and Victoria line. When we sort of landed around the same time. When we arrived, we were delivering 1 or 2 sleepers a night. We we were integral to increasing the output, and the best shift we ever done was at Mile End one night. We put 14 sleepers in one night. Now that's only 7 meters because the sleepers back then had to fit into the tunnel rings, and they were put in at 503 millimeters centers. So as I said, Dan is a specialist in this field, true specialist. He's been doing this for 16 years. So Danny boy, over to you. Take it away.
Thank you, Damien, and welcome everyone to my world. It's a very old and difficult environment, but fascinating and full of history. Now, a quick background about myself. So I've joined the railway in 2004 from a mechanical background in the Merchant Navy. After a brief 6 months with Truck Force, which is now TDU, I moved to Ruislip and Balfour Beatty in 2005 to be a DTR site engineer. My first site was Holborn to Tottenham Court Road westbound on the Central Line. And a few years later, I became a section engineer for Central, then Victoria Line, looking after all DTR closeout sites. And in 2012, moved to PNC team, where I delivered 10 deep tube PNC layouts over the last 2 years. After planning and delivering Walthamstow Blockade, I moved to Crossrail for 3 years as a track quality assurance manager. I returned here to my old family just over a year now. And in case you wonder where the photo is from, it was taken in 1923 near Camden Town. And yes, we visited this place in 2014, almost 100 years ago. So we're going to start with a history lesson and a few interesting numbers. I'll then briefly explain deep tube renewals methodology for those not familiar, chat to you about main challenges in the tunnels, and finish off with a quick look at what we're working on to improve delivery. Deep tube history and numbers. Right, if we go on to the next slide. London Underground's 11 lines total 408 kilometers in length. 45% of the network is in tunnels, of which there are 32 kilometers in subsurface and 149 kilometers in deep level tube. Few numbers to note: deepest station below street level is Hampstead at 58.5 meters. Longest section of tunnel is East Finchley to Morden via Bank branch on the Northern Line. That's 27.8 kilometers. And the maximum depth below ground level, again on the Northern Line, around Hollybush Hill near Hampstead, that's 67.4 meters below ground. In terms of turnouts or PNC numbers, we've got, I think, around 800 and just over 850 on running lines. It's about 1,100 in depot and sidings, but I know we have just over 200 PNC units in deep tube concrete on our network. Right, the tunnels. These are just cross sections showing the internal diameter of existing tunnels in London. Most deep tube tunnels have the same principle: 6 segments and 1 keystone. The keystone is used to lock the segments in place, and its location moves depending on the orientation of tunnel. Most tunnel rings are grey cast iron, apart from Victoria Line, who's got concrete rings. Brief history of deep tube tunnels. The Tower Subway is the first deep tube cast iron tunnel beneath River Thames in central London. In 1869, a 410 circular tunnel with 2.1 diameter was dug through the London clay using a cast iron shield. Today, the tunnel is used for water mains. Opened in 1890, City and South London Railway was the first deep tube level underground tube railway in the world and the first major railway to use electric traction. Today, its tunnels and stations form the Bank branch of the Northern Line from Camden Town to Kennington, and the southern leg of the line from Kennington to Morden. Central Line opened in 1900, and its trains are running in 2 circular tunnels having diameters between 3.5, that's White City to Liverpool Street section, and 3.7 for the remaining deep tube section. Victoria Line, this line was constructed in 1960s and was the first entirely new underground line in London for 50 years. Diameter increased to 3.8 meter. As a comparison, Northern Line extension due to open hopefully next year or 2022. Internal diameter for running tunnels, it's 5.2 meters. Crossrail, although late, it will be a fantastic new line with 6.2 diameter tunnels. Just to give you an idea, I can fit a Class 66 loco comfortably. Right, who built the tube? So a particular band of hard-working men known collectively as navvies, the vast majority being former tin miners from Cornwall or farmers from Scotland and Ireland that had come from building the canals. Construction methods used across London's growing underground railway improved since opening of the first line in 1863. Tunnelling shields, based on the same principle as the pioneering device designed by Mark Brunel for his famous Thames Tunnel, were used to build the tunnels of what today are Northern, Waterloo and City, Central, Bakerloo and Piccadilly lines. It was still a back-breaking job for the men working at the face of a tunnel shield, with the vast majority of construction work still being done by hand. Unlike the cut and cover method, which only required shallow trenches, the deep level lines were built far below ground with actual tunnels being built. Conditions were cramped, dark, cold and wet. They were working for a rate of pay that, although was cheap to the company, was actually generous in comparison to other jobs. By standards of the time, navvies were well paid. They could earn 25 pence a day. That's £30 in today's money, which was almost double to those who worked in factories. Many railways intentionally paid their navvies right next to a tavern owned by the railway company, this way getting most of their money back on a Sunday. Due to limited safety protocols, navvies were frequently injured or killed on the job. For each mile of rail laid, there was an average of 3 work-related deaths. Even so, it was said that it took up to a year to turn a common labourer into a navvy capable of excavating, and this is it, 20 tons of earth in a day. Right, quickly going through the photos. I've got top left from 1923. It's some tunnelling works at Mornington Crescent. Top right, 1924. Construction work inside the tunnel prior to laying track at Bank Underground Station. Bottom left, 1962 Victoria Line construction near Walthamstow running tunnels. And bottom right, 1946, 2 POA men undertaking repairs to a crossing. Right, I'd like to say, first of all, a big thank you for London Transport Museum for all the photographs and making my life easier. How did they do it? How did they build this deep tube tunnels? After they dug the tunnels, most track laying activities were done by hand, as shown in these photos. So we got top left in 1938, a group of men operating a series of winches for positioning track sleepers. Top right, same year, a walkman maneuvers 2 rail sleepers suspended from a chain winch. Bottom left, Northern Line permanent way gang laying a new track. The man with the loud hailer appears to be controlling the work. That's like an old Terry church. Bottom right, track laying in a tube tunnel near Highgate Underground Station. So as you can see, everything was done by hand, swinging hammers and knocking the track into position. Right, existing track form. So interesting fact, Central Line has the smallest radius on the entire London Underground. So we have Caxton Curve that's got 62-meter radius. Piccadilly eastbound at South Kent has got 89 meters. Bakerloo line southbound at Paddington has got 90-meter radius. So we're talking about very tight radius in the tube. The original track consists of timber sleepers and bullet rail with shingle filled channel. In platforms, there are concrete pits with timber pit blocks. Because of the age, this track is obviously life expired. Various attempts had been made in the past to introduce improved track forms. This included trying concrete sleepers using NTF 415, so-called hedgehog concrete sleepers. In the platform areas, we had trapezoidal pit blocks, rubber booted around pit blocks was also tried. Finally, direct fastening into concrete using healthy anchors was tried as well. In early 2014, Deep Tube began using Delco direct fastening resilient base blades. Several Delco types have been tried, but now the 195 model is the normal choice. Right, some fun facts about Deep Tube. Top right is the dead-ended tunnel. So at Elephant and Castle Tube Station, there's a false brick wall, and the tunnel actually continues for a few miles to Camberwell Station. Engineering works begun and then abandoned in the early 1900s, and the tunnel is now sealed. A recently announced extension of Bakerloo line to Lewisham via Old Kent Road and New Cross Gate has been chosen as the best route. Works are planned to start there in 2023. And depending on the final plans for the junction point, that could see the disused tunnel repurposed as additional storage for trains. In the middle, it's cooler below poster. So I always said that to my BTR colleagues, and I was not referring to temperature. When the early tube tunnels were dug, they were so cool down there, I mean 14, 16 degrees Celsius, that the cool tube was seen as a break from the summer heat on the surface. Why suffer on a bus in the heat when there's a cool tube to take instead, said the marketing man. A few more details about this actually later on when we cover the heat and ventilation. Bottom left, with a vertical rise of 27 meters and length of 61 meters, the escalators at Angel Station are the longest on the London Underground and the second longest in UK. There's actually a longer one at Heathrow Terminal 5. Shorter distance, another fun fact. Shortest distance between two adjacent stations on the Underground network is only 620 meters. The tube journey between Leicester Square and Covent Garden on the Pick line takes only about 20 seconds, but costs £4.90. That's the cash fare for zone 1. That's 25 pence per second, probably the most expensive ride on public transport in the world. However, it still remains one of the most popular journeys with tourists. Now that you've heard all this, Vid, I'm going to pass this on to you for a bit of a quiz time.
Thank you, Dan. Yeah, after the success of the quiz last week, we thought we'd do it again. So I'll just share the pin with you guys. If you log into kahoot.it and just enter 5776972, you should be able to join the quiz. I'll give it a couple of minutes so people have time to join. Oh, we've got Simon, Dave. There we go. They're all coming in now. Mike, nice to see you. Perfect. We'll give it a bit more time. This will cover some of the stuff Dan talked about as well, so I hope you guys were listening intently. Okay, we've got 23 players. I'll wait for 2 more. There we go. Okay, are you guys ready? Let's start. So this is the Deep Tube knowledge sharing quiz. The first question is, how many passenger journeys does the tube handle in one day? Is it 2 million, 8 million, 5 million, or 0.5 million? Remember, the quicker you answer, the more points you get. Three seconds left. Okay, 11 people got it right. Very, very nicely done. Churchy is on top. Nice one, Churchy. Second question is, which is the deepest LU station? Is it Covent Garden, Hampstead, Victoria, or Waterloo? 10 seconds left. 5. There you go. 25. So everyone was listening to you, Dan. You'll be happy to know. Who's in the lead now? LW's taken the lead. The third question, which station has the longest escalator?
Oh, that's
Is it
an easy one.
Hampstead, Westminster, Angel, or Clapham Common? Again, everyone's very quick in answering. Three seconds. 24. Yes, very good listeners.
This is too easy.
LW still in the lead. Question 4. What is distance between Covent Garden and Leicester Square? Is it A, 400 meters, 1,000 meters, 556, or 260 meters? Okay, 9 people. So yeah, getting closer, I'm sure. LW still in the lead. True or false, the average Londoner spends 11 and a half days every year on the London Underground. It's quite a long time. 11 and a half days. 5 seconds left. So 20 people got it right. So time for the podium. In third place, Yannick. Nice one, Yannick. In second, Jay. And in first place, it is LW. Very well played. Congratulations, LW. I just exit this and then pass you back over to Dan. There you go, Dan.
Thank you, Vid. So let's talk now a bit about DTR methodology. Right, we have various concrete track forms. We have timber on concrete sleepers encased in concrete in most tunnels. In platforms, we have timber or concrete pit blocks encased, that's lozenge or NTFs. Direct fix Delco base plates, pan roll, Sika resilient direct fix, that's mainly for tube line sites, and Sonneville concrete blocks. In the past, on Track Alliance project, we used to have possessions where we would deliver very labor intensive 100, 150 meters of plain line per weekend. Main reasons this was stopped was the manual handling, logistic complexity, and the poor quality of the completed works. At the moment, possessions are not granted for deep tube renewal plain line works. Majority of access is through engineering hours, typically from 1 to 5 for 4 hours, where the rate is now 3.5, 4 meters a night. When Track Alliance started recon in the early 2000s, the rate was no more than 2 meters a night, like Damien mentioned. But over the 5 years, the rate was increased to 5, 6 meters, 6 linear meters. That's 10 to 14 concrete sleepers per night at 507 mil spacings. greater access on Saturday nights. That's we're talking about 6 hours. We used to get better access on Saturday night, but since the introduction of night tube, this opportunity was lost. So these shifts were normally used for complex re-rail, realignment, a lot of welding. When it comes to DTR PNC works, we had Piccadilly Circus. That was the first one. Piccadilly Line 2009, Marble Arch, Central Line 2011, along with Bethnal Green same year. Liverpool Street on the Central Line, first time there in 2012 for the mainline turnouts, and then in 2014 to do the sidings. Banks Central Line, we were there in 2012 for a bit of a heavy maintenance, and we filled in an existing underground cavern culvert there. Then we had Walthamstow Victoria Line in 2015. We had a blockade over there. Camden Town, we visited Camden Town 6 times on the Northern Line. First time in 2014, and the last time in 2018. And then Paddington 2017. We've been there twice. Now, in the past, I want to talk briefly about sleeper popping. So there's a photograph Bond Centre there. The renewal of tube track by popping existing timber sleepers and replacing with new NTF 415 concrete sleepers was considered as an economic and efficient methodology when conditions permitted. The new concrete sleepers were positioned and secured in existing pockets using an approved rapid hardening concrete with a minimal aggregate size. And for those of you who remember, that was pyracrete with 5 mil aggregate. These days we're using 20-30 mil concrete, just so you know, for the bigger jobs. However, flat bottom rail with hedgehog NTF 415 concrete sleepers has quite a few issues. It's got poor noise and vibration performance. It's very stiff, causing a lot of rail defects and fastening failure on curves below 400-meter radius. Right, prep works in the deep tube. So I'm only going to go through some of the prep activities we don't see on a BTR site. So shingle removal throughout the installation section. Then once you've done that, temporary walkboards placed through sides, so you can have a sound emergency evacuation walkway and a safe walking route. Asbestos removal, I'm going to touch base on that in a minute. Temporary sleepers installed to hold track alignment during platform recon jobs. Then you got the site mobilization, because a majority of track recon materials have to be delivered to site prior to commencing the recon activities. Site prep drilling for bursting or breaking out where needed. And I'd like to spend a bit of time for posi conrail plinths or power cables. If you look at that photograph in the middle, obviously when you convert the bullet to a flat bottom, that will clash. So there's a lot of prep works involved. So first part of a recon shift is the removal of old sleepers and concrete. One thing to note here, so the new rail, once installed, will always be realigned to new design prior to reconditioning. Where possible, design levels will also be implemented, although typically a certain amount of this is undertaken during the actual reconning stage. So once the area has been identified, any design alignment adjustments are marked up by the engineer. Sleepers cut or popped out of their pocket. Concrete bursting carried out. Concrete separates from the engineering base. Manual breakers are used to reduce large sections of concrete that are too large to manhandle. Spoil created, packed, and swept. Right, second part, the installation of new base plates and concrete using top-down methods. So same as most of the slab tracks methodologies, we're using top-down method. Pre-assembled Delco base plates are hung on onto the rail. Shuttering installed using spacers to enable later on to install the GRP walkway. That's glass reinforced plastic. Track alignment checked against design. So for the engineering hour works, no jig supports are needed. The sections of track is too short to allow any movement. Clay apply around base and sides for preventing concrete to run out. Track components protected from concrete splatter. Rapid hardening concrete mixed and poured. We use various types of concrete, but Techrock and Instamac are widely the most frequent. Both 10-15 minutes workability and 1 hour for 15 Newton strength, which is enough for passenger trains to run. PNC recon, like I said, break out the engineering base on PNC sites. It's very challenging because of the size and depth required, and the uneven surfaces can create cracks in second stage concrete once poured. So I've got 2 photographs here. How much we changed from when we started in 2011, when we used manual rollers, and now we're using 6-ton gantry cranes. This is Liverpool Street versus Paddington. So the renewal of points and crossings on London Underground is a complex logistical challenge. In the tube sections, the existing turnouts are cast into the tunnel limber concrete. At the same time, there's a general policy for all renewals to replace bullet rail with modern, heavier flat bottom rail. This in turn requires the air-operated points to be replaced by more powerful electric drives, and Sherlock is a good example. In tube sections, the renewal constraints are even greater. So the work on a crossover is often split into 2 52-hour weekend possessions, with an inevitable impact on the timetable and inconvenience for passengers. The temporary sequencing of the works is critical and can often require plain lining of the main route, whilst the other sections of the turnout are broken out and replaced. The new design alignment is also often a constraint, as the new points and crossings have to be fitted within the existing tunnel space. Furthermore, there is an increased risk of engineering overruns because of the complexity of the work and the limited time and access available.
Dan, before we move on, there's actually a question that's come through. The question is, what happens to the gantry after the work is complete?
So all the gantry cranes we've installed have been passed on to the maintainer. And after a period of a year or 2 of us maintaining it, everything goes on to onto the maintenance department, and they are very beneficial, as they admit it. They get used quite often for deliveries and unloading heavier loads. So there was talks a while back for us dismantling some, but at no point we did that with any of the permanent gantries that we put in.
Okay.
Right. Deep tube drainage. So last week's drainage session spoke about drainage in more detail, and John O'Sullivan's presentation was quite informative. So there's no standard construction across all tube tunnels. They all, however, utilize a combination of common components: small half-round channels running longitudinally at the edge of the track, concrete channels within the 4-foot, usually shingle filled, small diameter, that's 75-100 mil perforated pipes within the channels, and then access chambers, bailing pits, sumps, pumps, associated control equipment. That's usual equipment. We are installing a permanent channel with a continuous GRP cover that also provides a very good walkway. I've mentioned earlier the GRP glass reinforced plastic, and there's a photo there on the left-hand side. Right, moving on to main challenges of deep tube truck environment. So first challenge, probably the most obvious one, it's location. Space. we have no room for mechanized vehicles to aid with manual labor activities. Although we're mitigating that, and we introduced, like I said, gantry cranes for big PNC jobs. We've got LG1 route approvals for TB250 RRVs and 3-ton mini diggers. A very big challenge is the age of the tunnels. So Holborn in 2016 in museum sidings, we removed a 1886 base plate still in service. You can see a photograph top right. Even though it was on the siding road, we're talking about over 100-year base plate. Obviously, tunnels are not well understood and catalogued until recently. There's a big safety risk if we lose a tunnel, and a very big reputational risk if we do lose it. There's always progressive degradation. You've got tunnel seepage and corrosion affecting the rail, concrete surface or drainage, and obviously will slow down the handback to the client. Tolerances, you got plus or minus 3 mil. That does require more attention to detail. Why? So on my first site, Holborn to Tottenham Court Road on Central Line, there were train shoe marks on the tunnel render showing just how critical clearances are. Storage, no cess in most tunnels. So most materials stored in cross passages. If you're lucky with not enough space, there's very strict storage license rules in place. And a good example is mile end derailment in July 2007 on Central Line, when a roll of fire blanket rolled itself out of a 10-meter long cross passage, causing the train to derail, luckily causing just a few minor injuries. There's a photo there on the slide on the left-hand side. If interested, more details about this, just follow the link to rail accident report. So there's a whole full report there at the bottom of the slide.
Dan, another question that's come in. So someone's wondering, how many engineering trains do we use on a DTR? Is it similar to BTRs or?
Obviously not, because mainly the deep tube sites are shorter for obvious reasons. So I would say for a fairly complex PNC job, I'd say no more than maybe 6, 7 trains. Usually an easier one, 4, 5 trains if you have easy access. But definitely no recycling. The only job we had trains recycled, I think, was the blockade. Or if we share the fleet with a BTR job like we had at Paddington.
Okay.
Right, moving on to asbestos. So as a not so fun fact, Steve McQueen did die from an asbestos-related disease. It was thought this was due to asbestos used in movie sound insulation and protective clothing and helmets he wore when racing cars. However, Steve removed asbestos lagging from ships while he was in the Marines. When planning a job or working in the area, remember, east end of Central Line, north part of Jubilee, and most of Northern Line are known areas to have asbestos, as shown on the map in the middle of the slide. When I started in 2005, most of the Victoria Line had the noise reduction shelf that has now been removed. Central Line sites, I reckon all platform jobs, or at least all the ones I've been on, had asbestos contaminated pit blocks that had to safely be removed by a specialist contractor. However, that takes a lot of time, and it's something that you need to plan when you look at similar jobs. Right. Moving on to ventilation and heat, Dave. So about 21% of the heat in the tunnels comes from the movement of train themselves, from aerodynamic drag and other frictional losses. The motor engine accounts for about 15%. The electrical and auxiliary system are the remaining 12%. But about half of the heat in the tunnels, though, comes from just one source, and that's from trains slowing down. Conversion of movement into heat by applying the brakes. London's deep tube lines do not have enough air passage to the surface to let the warm air escape, just like the subsurface ones have. We had up to 40 degrees Celsius on sites during weekend summer closures. So you can tell you how warm them tunnels can get compared to subsurface. Where does the heat go? So heat transfer into tunnel walls, about 80% of that. So 80% of the heat goes into the tunnel walls. Initial tunnels, like I mentioned, were built and operated at 16 Celsius. Mechanical ventilation, that's the big ventilation shafts, they only remove about 10% of the heat. While that heavy, thick clay is lovely to tunnel through, it's also a very good heat insulator. Over the years, the heat from the trains soaked into the clay to the point where it can no longer absorb any more heat. So tunnels that were a mere 16 degrees in the 1900s can now have air temperatures as high as 30 degrees Celsius on parts of tube network. Something which has been built into Crossrail stations design, so where possible, might be retrofitted to some London Underground stations, is under-platform air systems. So collecting the heat where it happens the most. On our DTR weekend works, mitigations we put in place, we roster additional resources, as if you think about it, only 4 or 5 hours productive. Obviously long breaks required. Big cooling fans have been used. You got a photograph of one over the last 5 years, reducing site temperatures only by 2-3 degrees.
Dan, again,
challenges.
Before we move on, I think it's quite a good statement made by Henry Fenn. He's saying there's a hazmat team at LUL who are arranging training sessions on specialist asbestos awareness. Maybe that's something DTR staff or people who work on DTR can get involved in.
Yeah, absolutely. Part of our Deep Tube PNC team had received this induction, and it's quite useful. I recommend everyone who's got half a day to attend. Right, moving on to challenges. So the most obvious one again is it's concrete track. So I'm gonna briefly touch on the costs of deep tube jobs. So compared to BTR, to ballasted track. So a BTR PNC, if a point 10 costs about £150,000, a deep tube one would cost £2 million. For plain line, on average, a BTR is about 3,500. For a linear meter, the deep tube is double, that's £6,500. So huge difference in costs. Why? Logistics. So the extensive logistics plans required. So we paid in the past 300,000 for road closures, 100,000 for pumping concrete, additional staff and risk mitigations, additional power for tools. The length of prep and follow-up works. If you had the luck to work on some of our DTR PNC sites, you know how challenging it is when we moved the whole Ruislip or Lilliebridge depot to the platforms and having to tidy up at the end. Access to stations, again, most deep tube stations are in central London. Running 300 metres of pipeline from outside station entrance to site is a task on its own. Those who remember Netherton Road shaft on Victoria Line understand how important and easy it is to get materials down to a deep tube site. Temporary works, scaffolding to support pipeline over escalators or down shafts. Temporary track design is needed for trains to run on panels not yet concreted. So all this temporary works that you don't usually see on ballasted track has to be considered. Drainage system incorporated into slab track. Most systems are casted into concrete. Additional breakout and clashes with track system. There's not enough clearances. A lot of problems. Civils and structures assessments for risk of damaging tunnel rings. weight of an overhead gantry, forces of push-pull realignment jigs. All these assessments have to happen before a deep tube job takes place. Another challenge is the experience. So I strongly believe we have the experience, but we don't have the practice. We had Bethnal Green, Liverpool Street, and most of all DTR PNC jobs were on timber sleepers that was easier to handle. They were realigned with jacks and concreted in using wooden wedges. DTR has changed since I started 15 years ago, and now we have to break out deeper. We use TRT and electric gantry cranes rather than manual handle everything into position. But however, if we have 1 or 2 blockades a year for the BTR sites, we only had 1 in 20 years for the deep tube. And that's 5 years ago at Walthamstow. Remember, deep tube tunnels are 36% of the entire infrastructure. Right. Improvements we introduced over the years. So I think the most important one, the DTR PNC team has had a culture of continuous development and a heavy focus on lessons learned. Some of the improvements: use of gantry able to lift up to 6 tons of materials, better management of the risks of buried services, the introduction of concrete bursting as a safer and more efficient alternative to breaking, the use of hippo mixers, excuse me, for engineering hours. Shims under the Delco base plates have been used during recon, meaning that the sleepers can go in lower than the original being replaced. Track alignment jigs rather than jacks and wooden wedges. Concrete blankets to speed up curing by retaining the release of heat during the chemical reaction. GRP baskets, saving shuttering time around stretcher bars. Approved and used of Delco resilient base plates for PNC configuration. Remember, Camden was the first site we did that. Use of Converge to provide live and more accurate understanding of concrete strength during the curing, and scaffolding pipelines rather than hand mixing, or those of you who remember, hand batching on the back of an engineering train. So all these improvements were introduced over the years. And just to summarize that, Vid, over to you.
So something that will really show what Dan was speaking about is a video. So I'll just share this video with you guys. Please let me know if you can see it and hear it. I'll just give me 1 second. Okay, here we go. Please let me know if you can hear it in the chat.
A really challenging weekend for Track Partnership that has been put off for a long time. Track Partnership have took this on board with Queen's Park going on at the same weekend. 2 challenging jobs for this weekend.
So this job's been in and out of the programme for many years, and part of the reason is due to the constrained nature of the site. So we have a roof over the top of the sheds, and also upright stanchions every 3.5 metres, and the challenge here is being able to find machines that can work in this environment.
So while we planned the job, we planned it for a 138 to lift the panels because it was a heavy lift machine, but all the dig and the stoning up, and tomorrow all the top stone will be done with these mini diggers. The rates are adjusted to it, and on the previous weekend, the 31, all the rates worked really well. The guys have found them really good, to be honest. Obviously, they're underground drivers, so they're used to tight constraints.
So one of the big complexities here has been working alongside Paddington. So we're passing engineers' trains from this worksite into Paddington's in order to leave the possession.
throughout the closure, it's probably been about 40 or 50 vehicles throughout the weekend in and out that we've had to deal with, as well as making sure we've maintained a route for the emergency services to St Mary's Hospital just up the road there. And we've had to have the police on standby for the concrete, and we've had streets monitoring the locations of the lorries so they can turn signals to green if required to get them on site on time before the concrete cures.
Yeah, we've had a really successful couple of weekends. We're just shifting about 28 cube of concrete on each day, and this concrete is a special type of concrete. It's got a special rapid hardener in it, which allows the trains to travel over it after 8 hours of us placing the concrete down there.
Professional, really professional this weekend. That goes from the planning and everything what has been put in for these challenging weekends, not just Paddington, also Queen's Park yet again. Absolutely outstanding.
Hope you guys enjoyed that. Really gives you an idea of the type of work that's done in the deep tube. Let me share this presentation again. Back to you, Dan.
Thank you, Vid. So moving on now to the last part of this presentation, future of the DTR and future developments. There are a lot of future developments in progress for deep tube works, and I'm going to lead on these innovations. I'm sure with my experience and support from London Underground, we will get there. And if anyone from the audience can help, please drop me an email or share your idea, and we can make deep tube renewals a much easier experience. So I'm going to run through a couple of ideas and plans we have for mobilization and prep works. So for future PNC renewals, we plan to install drainage channel in cess area to avoid breaking out the 4-foot drainage pipe like we did in the past. New PNC layouts to be pre-built in Lilybridge Depot, facilitating realignment training and familiarization along with reducing the cost of inspections. Pre-pour cess drainage channel and 6-foot area in engineering hours, reducing concrete volume. Engineering trains are stabled in various depots to take possession and access track earlier. For rail installation, planning to install PNC rails as conventional panels is something we're looking at. Exploring route approval clearances to install crossing rails, again, as panels rather than individual legs. For realignment, we're planning to design and install Cemex concrete sleepers every third Delco to hold alignment and avoid extra costs in engineering hours, follow up removing timber sleepers. Planning to design and install new realignment jigs. We're awaiting Lilybridge trials when a new layout will be built. Plan to use mechanized realignment plant like the one shown on the slide, top photograph. Concreting and curing. So we successfully already lab tested and trialed the new ready mix concrete to a pumpable mixed concrete to reduce curing time from 9 hours to 6 for 5 newtons strength, which is the required concrete strength for us to do most of the activities. While VCM2 project is taking shape, we're looking at maybe hand mixing quick hardening concrete in switch areas to install point machines and allow point fitters to work during mass pour curing time. So this will be a decluttering site during demobilization. We're exploring base plate covers to protect layout and reduce cleaning time rather than wrapping cling film. Conrail installation. Why not try and install the conrail before concrete pour so we can stick well during the curing time? And explore the use of concrete sleepers for preset conrail support. So all these are things that we're looking at. Most of them, I must admit, is for PNC. Another one big innovation is the VCM2. So VCM2 is a Balfour Beatty innovation being driven due to the historic problem of being unable to deliver a deep tube crossover in 52-hour possessions. Reason we only do 1 or 2 a year is lack of 72-hour closures. That tends to be Easter or Christmas. But VCM2 brings a solution to this problem, and ITT has ambition to reduce the closure further, even maybe deliver DTR PNC in 27 hours. So what does the VCM2 mean? There's no road closures, no mixing concrete by hand on site, diesel-free London by 2030, no delivering concrete to site by hand, no space allocation and manual handling pipeline, no carbon emissions for London, no scaffolding pipeline down the escalators, no materials and equipment, again via escalators. And that's it. I hope you enjoyed my my presentation. All I can say is these fantastic people build these tunnels and will proudly look after their work and take it further to into the future. So if there's any questions, if not, I've got some more historical photos. So we've got top left.
Oh, Dan, there are a couple of questions. So, how long have we been using the same methodology?
Especially with the PNC, we very slowly improved it, but this methodology was used by people installing track on the Victoria line 60 years ago. And I'm going to share after this presentation, I'm going to share a clip, a very interesting documentary about how Victoria line was built. And it shows you there a couple of sections, how they actually concrete it, how they actually put rail together. And it's probably not changed as much as we wish over the last 50, 60 years. Because of the size, again, everything or most of the things are still happening by hand. So sadly, not much.
Okay. Steve Harper's also said, Dan, this is a great session, and he's very proud of the work that we're doing at ITT. And he'll join us for the next one. Thanks for coming, Steve. Another question that came in, if you just give me 1 second. Is there any other metro system we can learn from that do similar DTR works?
I think we are world leading when it comes to track renewals and especially deep tube. I haven't heard anyone doing slab track deep tube renewals over a weekend. And as you probably know, or most of you guys know, the safety records at other metro lines in the world are not as good as ours. So I like to think that we're one of the best in the world, and I strongly believe that. So maybe there are ideas, but again, they are working on a metro system that was built 50, 60, 70 years ago. We're talking about 150-year-old tunnels. They're probably the smallest metro tunnels in the world. So even though the challenges are bigger, I think we're still the best in the world when it comes to renewals.
Right, okay.
Right, so if there's no more questions, I believe Vid, I'll leave that with you or with you, Damien, and explain what happens after this this presentation.
Yeah. Okay, Dan, thank you very much. Isn't it amazing, everyone, that we get to work on the oldest metro system in the world and surrounded by all the history and heritage? I know when we were down Plain Lane in museum sightings, there was some numbers on the wall that related to the bunks for the air raid shelters during the war. So we're surrounded by it every day when we work there. Also, I'd like to thank Steve for joining us. Steve Harper, he's head of engineering at Balfour Beatty Rail. So it's his first knowledge sharing session. Looking for some feedback and a good catch up after this. Now, looking forward to Craig Williamson, also known as Rooney to his friends and some of his enemies, next week on the importance of a good, detailed dilapidation survey. So Craig has 13 years experience in PWA. He's worked his way through the Balfour Beatty apprenticeship scheme. and he graduated in civil engineering and worked across Track Alliance, Track Partnership, and ITT. He worked outside Balfour Beatty for a spell on Network Rail and Crossrail, and he was even in one of the competitors' bid teams when we were tendering for the ITT tender. Now, a fun fact about Rooney, and not a lot of people know this, but Rooney actually had a nose job for his wedding. Now, that's the truth. It's a pity that they didn't give him a normal nose instead of giving him one like Gary Duggan. But seriously, Rooney is a P-way and drainage specialist, and he's a great asset to ITT. And we will all learn the importance of an accurate dilapidation survey next week. Now, this came up during a few of the previous presentations. Daz Kind and Di Strong and Simon Atkins have all spoke about this in the commentary. So it's something that we all think we could do better, and it will improve our defect-free delivery approach. So thank everyone for joining in and your continued support. Please feel free to pass the invite on. This is a good platform, and spread the word. It's a good interactive session. I know I enjoy it. And we do get a lot of input from the delivery teams, and it's good to touch base with all our colleagues across ITT on a weekly basis. I know I miss working with some of you more than others, I'd say. I'm also looking forward to our first Thursday night out and a couple of lovely frothy pints. If this lockdown continues much longer, I think we should have a virtual ITT soiree. I'm not sure about that, but we can see what you think. So have a think and get back to me or Dan with suggestions. And that's it for now. Thank you, Slán, and goodbye.
Thank you.
Cheers, guys. Nice one. Thank you.
Cheers, David.